we go again. So I can sub all that in. And I get 1 over 1.00287 times 1 minus 1 over 1.00287 to the power of 240 all over 1 minus 1 over 1.00287. This is where I normally would like store that in my calculator under A so that I don't have to keep retyping it. You don't have to. I just find it a bit easier. Right, so we have that multiplied by 1 minus that to the power of 240 over 1 minus that. Okay, so when I do that, I am getting 173.284326. That, if I zoom out a little bit, is the answer to the bracket, which was part of a bigger equation. So I'm just going to sub that back in. So I get 360,000 equals A times 173.28 blah blah blah. I've kept the whole number in my calculator, so I will be using the whole number. So divided by 173.28. Sorry, I shouldn't say I'll be using the whole number. I'll be using all the digits. So divide both sides by 173.28. And that gives me an amount of, hopefully the same. Is that what I got? 2077.51. Yes. Yeah? So I just wanted to show you that. That's the series way of doing it, but it wasn't necessary here. Okay, Mary's concerned that the monthly repayments on her mortgage over 20 years may be too high for her to repay. She agrees to pay €1,800 per month. Find how long it will take her to repay her mortgage. So, I think I can use amortization here. Don't see why not, because it's still the end of the month. Everything else stays the same. So it's going to be the same formula as up here. Oh, this one, I think. But I don't know A. I think. Sorry, I do know A. I don't know T. It's how long. So A is the amount she pays, which is 1,800. The principal is 360,000. I is 0.00. Why is it not writing? 0.00287. This is 1.00287 to the power of T. And then 1.00287 to the power of T minus 1. It worked there, didn't it? Just as I was Xing out of it. Okay. So if I multiply by this, so if I multiply by 1.00287 to the T minus 1, I'll cancel that out, but then I have to do that on this side. So that gives me 1,800 times 1.00287 to the power of T minus 1. And that equals, now these two don't have a power, so I can multiply them together. So that is 1033.2 times 1.00287 to the power of t. Yeah? This I can multiply distributively, sort of. I can't really do much with the first part because it's got a power, so I can kind of only just put them together. Second one I can multiply, 1800 by minus 1 is minus 1800, so that one's fine. And this one I also can't do any better with because of the power. Now what I will do is I'll gather the powers together whenever they come up. I am still here. Right, so we gather the powers together. So I'm going to minus the 1033.2 times 1.00287 to the power of t. And I'm going to minus 1033.2 times 1.00287 to the power of t. And then I'm going to plus the 1800 to cancel it from here. And I'm going to plus the 1800 over the far side. So these both have the same variable, which means they can be subtracted. So it's like having 1800x minus 1033x. You can subtract them and just keep the variable. So 1800 minus 1033.2 is 766.8 times 1.00287 to the power of t equals, and all I have on the right there is 1800. This is an unknown power, so this looks like it's going to be logs. So divide by 766.8, divide by 766.8. So I get 1.00287 to the power of t equals... is that a big number? Okay, I'm going to leave it as a fraction because it's a really awkward number. Yeah, so I can do it the same way I did it. I feel like this is earlier in this test. You know, you take log of 1.00287 and then same over here. 00287. So we can bring the t to the front. And because the base and the argument match, it's just 1. And this is log to the base 1.00287 times 500 over 213. So that base is not a fraction and it's not inequality, so we've none of that crap from earlier. So log to the base 1.00287 over answer equals, so I'm getting 297.75, so approximately 298 months. Yep, and that's worth 15 marks. All right, and the last one, I had a look at this earlier because I saw the two percentages. I'm not going to include this in the test because I have never seen a question like this before. I'm going to show you how to do it, but I'm not going to include it because it's weird. Anyway, so Pat is planning for his retirement and he wishes to calculate the value of his pension fund. Of the pension fund he requires when he retires. He wants a fund that from the date of his retirement will give him a payment of 30 euro at the start of each year for 25 years with an increase of 2% per annum. He assumes the fund will earn an annual equivalent rate of 3% over the period of the payments. Find the value of the pension fund that Pat requires when he retires. So, This is a weird one because, first of all, it seems like it's savings, but it's not. He is going to be getting this money kind of the same way that you would get a loan, or the same way you would pay a loan, as in he's getting 30 grand at the start of the first year, and then 30 grand ish at the start of the second year, and then so on and so forth. So we will be using present values because all of those payments, we have to date them back to the beginning of his pension, and then he needs to have that much money there. So he needs to have, say, a pension of €500,000, so that over the coming years he can then get money in increments. But the money needs to be there at the start, so that's why it's like a loan. It's just divvied out to him over the course of time. Okay, so it is kind of a weird one because generally savings is future values, and a pension you would save for, but we're not talking about him saving for his pension here. We're talking about when he's claiming his pension. So it's like a loan. It's like on the day of his retirement, he wants to have this much money in his account, and then over the next however long he lives, he's going to start taking this money out. So he has the use of the money in exactly the same way he would if he got a loan. I hope that makes sense. So there's a certain value of his pension. His first payment is just 30 grand. It happens at the start, so there's no interest on it or anything like that. Now, this is the weird bit. So the second year, right, we want a present value. So 1 plus 0.03 is the AER, and we want that to include 1 year. Yeah? But the other bit, the bit where he says that he's going to receive 30 grand at the start of each of 25 years with an increase of 2% per annum, he is not going to receive 30,000. He is going to receive 30,000 plus 2% compound interest. So we have to do 1 plus 0.02. So the amount that we're present valuing is not 30,000. It's 30,000 plus an increase of 2% that we're present valuing. So that is actually 30,600 is the payment he's going to get at the start of the second year, which then needs to be present valued back a year so we can figure out how much he needs to have on his retirement date. So this is unusual. I mean, it makes sense, but it's definitely unusual and not something I showed you, or something that I think is a logical leap, as in, like, I think it's tricky enough. So then we have 1 plus 0.02 to the power of 2 over 1 plus 0.03 to the power of 2. Okay, so this one here is the start of year 1. This one here is the start of year 2. So it's the start of year 2, so that's why it contains 1 year's interest. This one here is the start of year 3. So start of year 3 means it contains interest from the first year and the second year. And then we go on to the last one. He said 25 years, and my power is behind my year, so it's going to be 24 is my power, yeah? Over 1 plus 0.03 to the power of 24. All right, so that's kind of it. Like, it's just a geometric series after that. So I'm going to take out the 30,000, which leaves me at 1 plus, and then I've got 1.02 over 1.03 to the power of 1, plus 1.02 over 1.03 to the power of 2, all the way up to 1.02 over 1.03 to the power of 24. Yeah, same again. I'm going to take the bracket and I'm going to SN the bracket. So it's a times 1 minus or to the power of n over 1 minus or. A is 1, or is T2 over T1, which is 1.02 over 1.03, and n is the amount of terms in the sequence, which is 25. Yeah, so obviously 1 to 24, and then the 1 at the beginning, so 25. Okay, so we sub in, and we get 1 times 1 minus 1.02 over 1.03 to the power of 25. And that is over 1 minus 1.02 over 1.03. Okay, fraction 1.02, 0.03, power 25, brackets over bracket 1 minus fraction. Okay, so I'm getting 22.2930563. Okay, and that is part of this equation up here. So F equals 30,000 by 22.293, and again I've kept the whole number in my calculator. So the final amount of the investment, so I'm getting 668,791.69 to the nearest cent. I'm just going to check that that's what they asked. Give your answer correct to the nearest euro. So 668,792 euros. So that's how much he would have to have sitting in his bank account on the day he retires to be able to get these payments each year for 25 years. Okay, so like I said, it was worth 10 marks, but I'm not going to include it because I mean, it could come up. It makes sense. It's just, I've not seen it before in all of the papers I've done. I don't know if it was an intuitive next step. So anyway, I'm not going to include it. So for that last one, we have 15 and 5 is 20, and 10 is 30, and 5 is 35. So that is 35. Wouldn't have been 50 anyway. Yeah. So 70, it's actually out of 100. All right. Let me know if you've still got any questions.